In the frigid reaches of our solar system lies a mysterious and uncharted expanse, known as the Kuiper Belt, a cosmic ring of icy remnants from the early solar system, extending far beyond the orbit of Neptune. Although the existence of this frosty home to countless comets and minor planets was only confirmed in 1992, it has already begun to reveal astonishing secrets that challenge our understanding of the outer solar system. The James Webb Space Telescope, designed to peer into the farthest reaches of space, has turned its gaze to this distant frontier, uncovering extraordinary insights. This region, once considered a cold, barren expanse, may conceal not only unknown planets but also the potential for life. Recent observations suggest that some of the icy bodies within the Kuiper Belt might radiate heat, hinting at the possibility of subsurface oceans or even extraterrestrial life. The history of the Kuiper Belt is closely linked to the search for Planet 9, a suspected planet that has been heavily researched and debated. The idea of Planet 9 was first raised in 2015, when astronomers discovered the unusual atmospheres of some distant objects in the Kuiper Belt. These objects, including the dwarf planet Sedna, exhibit elliptical orbits and shapes that defy conventional explanations. The influence of gravity suggests that these accretions could be attributed to a large but unobserved planet lurking outside the solar system. About 10 times the mass of Earth's crust, it orbits the Sun at a distance of 400 to 1,500 Australian dollars, and is 20 times farther from the Sun than Neptune, according to astronomer Mike Brown of the California Institute of Technology. Despite the overwhelming evidence and over 90% probability of its existence, Planet 9 remains, hidden in the outer reaches of its orbit. The search for Planet 9 is more difficult due to the low light and great distance. It may have a faint internal luminosity of 0.006, compared to Neptune's 0.01, which is undetectable with today's telescopes. In addition, the planet's low emission of heat, mostly in the infrared region, hampers search efforts. According to model calculations, the temperature on Planet 9 is about 47 K, which is slightly warmer than the background temperature of the Kuiper Belt. This means that finding Planet 9 requires advanced observational techniques, especially in the far infrared spectrum. As astronomers continue to search for this hypothetical world, the Kuiper Belt itself will become an area of exploration. The discovery of the first non-Neptunian object in the Kuiper Belt in 1992 was a breakthrough that confirmed the existence of this distant region. The Kuiper Belt extends 30 to 50 Australian dollars from the Sun and contains more than 70,000 objects more than 100 kilometers across. But the smaller ones, less than 10 kilometers in diameter, are difficult to detect because of the great distances. The size of the Kuiper Belt, which is 20 times larger and 200 times larger than the asteroid belt, makes it a treasure trove of science. One of the most significant developments in recent years has been the discovery of extreme conditions in the Kuiper Belt. Observations from the James Webb Telescope have detected signs of nearby methane production on the dwarf planets Eris and Mach. This discovery challenges the idea that the Kuiper Belt is an icy wasteland. Instead, it suggests that these distant worlds may have strong cores that can bring water and gas to the surface. The appearance of young methane deposits suggests that there may be a subsurface ocean or an internal heating process within these ice bodies. This revelation is consistent with findings from NASA's New Horizons mission, which has explored Pluto and its moons, and suggests that the Kuiper Belt is more massive than previously thought. Other dwarf planets in the Kuiper Belt could have similar subsurface oceans, which could offer good opportunities for extraterrestrial life. To further investigate these possibilities, researchers Christopher Glynn of the Southwest Research Institute are planning to go deeper into the Kuiper Belt. Dedicated research can provide valuable insight into the physical and atmospheric properties of these distant objects. As technology advances rapidly, these efforts may reveal surprises that challenge our current understanding of the solar system and the potential for life beyond Earth. The search for knowledge in this icy landscape is far from over, and future discoveries may change our understanding of the solar system and our place in it. The Kuiper Belt, from 30 to 50 Australian dollars from the Sun, represents a large, cold region that was proposed but not confirmed until the early 1990s. This distant region, similar to the planetary debris field, is believed to be the remnants of the early solar system, full of icy bodies and small planets left over from its formation. The discovery of the first extra-Neptunian object in 1992, named 15760 Albion, was a major step forward in confirming the existence of the Kuiper Belt. The confirmation helped bolster theories put forward by astronomers Jan Hendrik Everett and Gerard Kuiper, who speculated about the existence of such a distant ice deposit long before observational evidence was available. Everett's model proposed a spherical shell of comets extending beyond Neptune, while Kuiper proposed a disk-like belt beyond Neptune's orbit. The discovery of this icy region confirmed the Kuiper hypothesis and marked a new era in our exploration of the outer solar system. Despite new discoveries since then, the Kuiper Belt remains a deep mystery. The number of bodies in this belt is staggering, with estimates of over 70,000 bodies over 100 kilometers wide. However, due to the great distance and small size of many of these objects, identification and study remain a major challenge. The difficulty of observing objects smaller than the Kuiper Belt was revealed in 2019 when a team of scientists discovered an object smaller than 10 kilometers in diameter for the first time. The discovery confirmed that there was little else in the belt, but also highlighted the limitations of current detection technology. The Kuiper Belt's vast and sparsely populated area means that many of its inhabitants remain hidden from view, awaiting detection tools and techniques. As scientists push the boundaries of what we know about the Kuiper Belt, the possibility of finding a ninth planet remains exciting. The idea of Planet 9 came from the discovery of different orbits between distant bodies in the Kuiper Belt. These objects, like Sedna, show elliptical orbits that are difficult to explain and do not imply the presence of a large, undetectable planet. Planet 9 is thought to be larger than Earth, and its mass is calculated to be 10 times that of our planet. Its probable orbit, extending between 400 and 1,500 Australian dollars from the Sun, is very distant and difficult to observe directly. Despite many searches, this planet remains elusive, and its life and properties are being heavily speculated and researched. The search for Planet 9 is more difficult due to the planet's low brightness and distance from the Sun. Theoretical models suggest that Planet 9 could have a temperature of 47 K, which is slightly warmer than the surrounding space. The low internal luminosity means that the universe cannot be seen by most telescopes. In addition, the low temperature of heat, mainly in the infrared region, requires special inspection methods for detection. The challenge of finding such a distant and faint object shows the limitations of current technology and shows the need for more powerful instruments and newer methods to explore the outer reaches of the universe. Solar System. Recent advances in technology and observational methods offer hope for future discoveries in the Kuiper Belt and beyond. The James Webb Space Telescope, with its unique capabilities, is beginning to provide new insights into this distant region. The discovery of nearby methane activity on dwarf planets such as Eris and Makemake suggests that the Kuiper Belt may be more active and potentially life-threatening than previously thought. As scientists continue to analyze these discoveries, they will support other missions to explore the icy worlds of the Kuiper Belt and explore the potential of the subsurface ocean and life. Trying to unravel the mysteries of the Kuiper Belt will not only deepen our understanding of the structure of the solar system, but also expand the possibility of finding life beyond Earth. With each new discovery, we approach fundamental questions about our place in the universe and the potential for life in unexpected corners of the world.